Hello friends, today we are going to discuss directional derivative and first of all we will read the definition of partial derivative. Now let f is a function of xy be any real valued function, then partial derivative of f with respect to x at any point ab is given by this limit. Limit h approaches to 0, fa plus hb minus fab over h. Here we will find the partial derivative with respect to x. Therefore, only the value of x coordinate will change here. The value of x is a plus h here, and value of x here is a. But in both points, the value of y is equal to b. We will not change the value of y because we will find the partial derivative with respect to x. Now, what is the distance between these 2 points? That is h. Now, we will define a plus hb, this vector, as a final vector and ab as a initial vector, and h is distance between initial and final vector. This is the final vector. We can write it as ab plus h0. So we will taking common h from this vector, we have h10. Now look at this vector 10. This vector is a unit vector, and what is the direction of this vector? The direction of this vector is along x-axis in the changing direction of x. Here we are calculating the partial derivative with respect to x. Therefore, the direction of this unit vector is changing direction of x. Now we can write the final vector as ab plus h10. What is ab? ab is the given point at which we have to calculate the partial derivative. What is h? h is a small scalar. So ab is a given point, h is a small scalar, 10 is a vector that gives us a direction. Similarly, what is the definition of partial derivative with respect to y? This is equal to the limit h approaches to 0, fab plus h minus fab over h. Here we will find the partial derivative with respect to y. Therefore, the coordinate of y will change, but the coordinate of x remains same and equal to a. Here a b plus h is a final vector and ab is the initial vector, and again h is a distance between initial and final vector. Again we can write ab plus h as ab plus 0h. After that we can taking common h from this vector and we get h01. Now look at the vector 01. This is a unit vector, and what is the direction of this vector? The direction of this vector is changing direction of y. This vector is along y-axis. Here we will calculate the partial derivative with respect to y. Therefore, the direction of this vector is along y-axis. Now, the final vector, again, we can check that final vector can be written as ab, the given point, h is a small scalar, and 01 is a unit vector that will give us a direction. Now, what happens if you find partial derivative along any direction except these two perpendicular directions? Then how can you find that derivative? Suppose you are interested to find partial derivative in the direction of AB, then how can you find that? Suppose this angle is a theta. We need a unit vector in the direction AB. because when we find the partial derivative with respect to x or with respect to y, then we need unit vectors 0 1 or 1 0. Now we are going to find derivative along the direction AB, therefore we need some unit vector in the direction AB. So what is that? Suppose that unit vector is AB. What is the length of this grid line? This is B. Similarly, length of this line is A. We know that the length of unit vector AB is 1. Therefore, we will consider the length of AB is 1. Now, what is the value of A and B? We can easily find it as A over 1 is cos theta, as this angle is theta. So B over 1 is sin theta. So value of A and B is sin theta and cos theta. So this vector is cos theta, sin theta. Therefore, unit vector in the direction of AB, the direction that makes angle theta with the x-axis, is cos theta, sin theta. Now, what is the final vector and initial vector in the direction of AB? Final vector, we know that final vector is given point plus small scalar into unit vector that gives us a direction. Therefore, final vector is of the type AB, that is given point, H, that is small scalar, and cos theta, sin theta, that is a unit vector that gives us a direction of AB. So our final vector here is A plus H cos theta, B plus H sin theta. Initial vector is again AB, and distance between initial and final vector, you can easily check that distance between initial and final vector is again H. Therefore, we will calculate f of final vector minus f of initial vector over distance between these two vectors, that is H here. So this derivative is called directional derivative, not a partial derivative, because both the variables are changed here. Value of x here is A plus H cos theta, here is A. The value of y here is B plus H sin theta, here is B. Therefore, both the values are changed. So this is not a partial derivative. So we will call it directional derivative of f at point AB in the direction of cos theta sin theta.